All right. So before, if I gave you something like x squared plus 1 times x minus 3 and told you to do the derivative of this, what would you do? You would FOIL first. And then you could do your derivative, which would be 3x. Okay. And that's all well and good. It doesn't take very much time to FOIL that out, so that is no problem at all. But what if I gave you something like this? Do you want to sit and multiply all of that out to do the derivative? Danny wants to, so we'll come back to him in a little bit. Let us know what you get for your answer. But I would prefer to not spend all my time distributing that. Or sometimes we will have things that we can't just multiply out. Like if I gave you x times sine x. There is absolutely no way to just write that as a single term with only one x in it. So we need another option, and this is the product rule. So, do you guys want me to prove where it comes from, or you just want me to give it to you? Do you guys even pay attention when I do this? No. Depends. I'm going to just give you this one. Okay. What this says is if f and g are both differentiable, that means they both have a derivative. The product rule says you can do f times the derivative of g plus g times the derivative of f. Or in other words, if you have f times g, that becomes f times g prime plus f prime times g. In other words, what you'll do is one derivative at a time. We'll do the derivative of one function, keep the other one the same, plus, and then you split. Okay? We could extend this if we had like 3 things. We just do one derivative at a time, and we can work through it that way. So let's try a problem. If I want this derivative without multiplying it out, this wouldn't be a horrible one to FOIL, and sometimes you might find just because we have a product rule doesn't mean you have to do it that way. So if you want to simplify first, there are cases where that's going to be faster. If I want this derivative, we do one derivative at a time. It doesn't even matter which one we do first. So if I just kept the first one the same, times the derivative of the second one. What is that derivative? 6x minus 5. Plus, now I'm going to do the derivative of the first parenthesis. So what's the derivative of 1 minus 4x cubed? Times, and this time I leave the second one alone. Let's go ahead and clean this up and combine our like terms. So now it's no big deal to just FOIL those things. We would get 6x minus 5 minus 24x cubed plus 20x cubed. This one, if you distribute your negative 12, we get negative 36x to the 4th plus 60x cubed minus 24x squared.
What if you get a 24x?
Thank you. Okay, combining like terms. If I Combine those two, the x to the fourth, we get negative 60x to the fourth. 20x cubed and 60x cubed is 80x cubed minus 24x squared plus 6x minus 5. This one really is a toss-up. It might have been faster to multiply out the original and then do the derivative. Sometimes it's faster to multiply first, sometimes it's not. So you have both options now. Do you guys understand how we got to this point? So we are just going to keep working on this. This one is one that we have no other option. If I have x times e to the x, I can't just multiply those things together. So I am forced to use the product rule. I know I have to use the product rule because I have two x's here. I have an x and then I have the e to the x. So there are two x's, so we have to do the product rule. So the product rule is the first, which is x, times the derivative of the second. What's the derivative of e to the x? E to the x. Plus the derivative of the first, so the derivative of x, 1, times the second, which is e to the x. So I get x e to the x plus e to the x. Okay. Part A, okay? Part B says find the nth derivative. So we're basically seeing if we can find a formula for what these derivatives are going to look like. We have done the first derivative. Let's work out the second and maybe even the third and see if we can notice any patterns. If I did the second derivative, do we know what the derivative of x e to the x is? Yeah, isn't that the answer we just got on part A? So we could either redo the product rule or realize this is the same term we originally did the derivative of. So when we do the derivative, we're going to get this again. Plus, what's the derivative of e to the x? So this one turns into x e to the x plus 2 e to the x. Let's all see how I did that. So I kind of shortcutted it. The first thing we had to do the derivative of was x e to the x. I didn't rework the whole thing out because the original problem was x e to the x. So the derivative of this is just the answer I got. So this represents the derivative of that first term. Then I have to do the derivative of e to the x, which is e to the x. So I got to that answer. If I want to do my third derivative, what is the derivative of x e to the x? X e to the x plus e to the x from part A. Plus, what would be the derivative of 2 e to the x? So 2 e to the x, isn't it? So if you simplify this, you get x e to the x plus 3 e to the x. So let's see, do you pick up the pattern? Every term has an x e to the x. The first derivative had 1 e to the x. The second derivative had 2 e to the x. The third derivative had 3 e to the x. So the nth derivative would be what? So we did a few derivatives, found the pattern, and we are able to come up with the formula. So if I asked for the 500th derivative of this, you wouldn't have to do it 500 times. You could just say it's going to be x e to the x plus 500 e to the x. Now most functions don't necessarily have patterns just like this. It mainly happens with your e to the x and your trig functions, which we haven't talked about yet, but sometimes it does occur. Questions there? Okay. Let's look at this one. So if I want this derivative, there are two options. What are they? FOIL it first, like we would have done yesterday, or product rule. Okay? Doesn't matter a bit to me how we do it. Since I'm practicing the product rule, I'm probably going to do it that way. But this is a problem. It would probably be a little bit faster just to FOIL it first. So totally up to you. Either way, though, you do need to rewrite the second one as x plus, what is the square root of x? Okay, let's work out both ways. So option one, like we did yesterday, if I FOILed, we would get 3x squared plus 3x times x to the 1/2, you add exponents, so 3x to the 3/2 plus x to the 1/2. So then your derivative would become 6x plus 3 times 3/2, so 9/2, x to the 1/2. What's the derivative of x? 1 plus 1/2 x to the negative 1/2. Okay, so that's option one. Multiply it out. If it's just two binomials, I recommend this option. It's probably going to be a little faster for you. Option two is the product rule. So you do one derivative at a time. So I'm going to keep the first one the same. Times the derivative of the second would be 1 plus 1/2 x to the negative 1/2. Plus derivative of the first would be what's the derivative? Times the second. And so if you chose to, then you could FOIL this out and simplify. Look to see if we have any like terms, and we do. The x to the 1/2, if you add those, you get 9/2 x to the 1/2. I wrote 3x squared here, and it is not, is it? It's just a 3x. So then you can combine your 3x's. So we get 6x plus 9/2 x to the 1/2 plus 1 plus 1/2 x to the negative 1/2. So two options, same derivative. You can now use either one. Do you have a question?
No.
Look at this one. Alright, this has a lot of variables in it. We only know how to do the derivative with one variable at a time. Because this is f of t, that means t is the variable. A and b here, we're going to treat them just like constants. Okay, so there's some number, we just don't know what they are. So if I asked you to do this derivative, would it be faster to multiply or do the product rule? Which one do you think? Maybe multiply. I mean, it's really a toss-up either way. If you multiply first, this is like a t to the 1/2. So if you distribute that, you get a times t to the 1/2 plus b times t. 1 plus 1/2 would be 3/2. So the derivative, exponent comes down, so 1/2 times a. You could write a 1/2 a, you could do a over 2. Subtract 1 from the power, so that's a negative 1/2. This would be a 3/2 b times t to the positive 1/2. So this one, it was pretty easy just to multiply it out first. If we did product rule here, it would be the first, so t to the 1/2, times the derivative of the second. What would be the derivative of a plus bt? B, right? Derivative of a would be 0. B times t, the derivative of t is just 1, so we just get a b there. Plus the derivative of the first, derivative of t to the 1/2 would be 1/2 t to the negative 1/2 times the second. So then you can simplify. When you multiply these, you add your exponents. Negative 1/2 plus 1 is positive 1/2. So then those are like terms, you can add them together. And we get the same answer. So I'm working these both ways because 2 reasons. I want you guys to see that we get the same answer either way. I also want you to try to get a feel for what your most effective method might be. You know, on this one, it's probably faster just to go ahead and run that t through at the beginning versus doing the full product rule. But sometimes you have things that you can't just multiply together, or you have things that might be pretty time consuming to FOIL out. So in that case, the product rule is necessary. Let's do this problem. F of x is the square root of x, or you could write that as x to the 1/2 times g of x. I don't know what g of x is. It's some function, but I didn't tell you what it actually was. I am telling you that g of 4 equals 2 and g prime of 4 equals 3. Thank you. Find f prime of 4. So we first have to do this derivative. And in this scenario, we have no option except to do the product rule because I don't know what g is. So the product rule of this would be the first times the derivative of the second. What would be the derivative of g of x? G prime of x. Because I don't know what g is. It's just representing some function. plus the derivative of the first. Derivative of x to the 1/2 would be 1/2 x to the negative 1/2 times the second one, which is just g of x. I am asking for f prime of 4. So if I plug a 4 in here, what is 4 to the 1/2 power? What is g prime of 4? Plus 1/2. Okay. 4 to the negative 1/2 power. That means like 1 over the square root of 4. 1/2 times g of 4 is 2. So we get 6 plus 1/4 times 2 is 1/2. So 6.5 is our final answer. So we did a derivative without even knowing what our function was. I'm probably going to do 2 more and then I'm going to stop for today. The second piece that we have to talk about is the quotient rule. You have this definition here from the book, which looks really confusing. If I want the derivative of f over g, so if I ask you for the derivative of this thing, it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, so the product rule, we did one derivative at a time and added them. Quotient rule, you're doing one derivative at a time but subtracting them. The difference is, in the product rule, it didn't matter which one you did the derivative of first, but for the quotient, it is going to matter because you're subtracting. A little trick that sometimes helps with this. Okay, you're going to kind of look at me crazy the first few times, but it sticks after a bit. We could say low d high minus high d low over low squared. Okay, low d high, so it's the low one times the derivative of the high one, minus high, so the top one, d low, the derivative of the low one, over low squared. So I'm going to say that a lot when we do the quotient rule, and it will kind of stick after a bit, and just a way of help you remember what order we're doing these things in. Okay, so I would like to try a couple quotient rules and then we'll probably quit for today. All right, let's talk about this one. Do you think it would be beneficial to do the quotient rule here? Is it necessary? Not really. We only have one term on the bottom. If you can simplify first, do it. The quotient rule is a little more time consuming than some of our others, so it's not necessarily going to be a fast option for you. So if you only have one term on the bottom and we can simplify this algebraically, we need to do that first. If I did, okay, 5x to the fourth over 2x squared, that would just be a 5 over 2x squared. 6x over 2x squared, that would be to the negative 1 power. 7 over 2x squared, that would be just 7 over 2x to the negative 2. So your derivative, 2 comes down, 5 halves times 2 is 5, subtract 1 from your power. Negative 3 times negative 1 is positive 3x, negative 1 minus 1 is negative 2. 7 over 2 times negative 2 is negative 7x, subtract 1, so negative 3. So just because we have the quotient rule doesn't mean we have to use it. If it's just a single term on the bottom, simplify it first. That'll save you a lot of time. All right. Let's do one where we can't simplify first. Because the denominator has 2 terms, there is no way to just break this up. So we have to do the quotient rule. So quotient rule is low, so that's the bottom, x cubed plus 6, d high, derivative of the top. What would that be? Minus high, so the top, d low, derivative of the bottom. Over low, so the bottom, squared. Okay. We are going to do a little bit to clean this up, but we're not going to any great lengths. I am not going to mess with the denominator. The numerator, we do need to multiply this and see if we can combine any like terms. So if I FOIL, I get 2x to the 4th plus x cubed plus 12x plus 6 minus, this one if I distribute my 3x squared, we get 3x to the 4th plus 3x cubed minus 6x squared over the denominator. What else would I need to do? Distribute the negative and then combine like terms. So 2x to the 4th minus 3x to the 4th is negative x to the 4th. 1x cubed and negative 3x cubed is negative 2x cubed. I have a positive 6x squared, a 12x, and a positive 6 over x cubed plus 6 squared. And that is my final answer. Typically when you do quotient rule, it's going to get uglier each derivative you do. You know, with polynomials, they kind of got a little bit shorter and prettier each time. That is not the case with the quotient rule. It's going to be getting uglier. Other questions on that?
If you were to satisfy this, would you just do, would you have to do the quotient rule?
Yes. And so you would have, in order, based on what we know right now, to do the derivative of the bottom, you would have to go ahead and square this out and then do the quotient rule again. All right, let's try a few more quotient rules. I want everybody with me on this one. Let's try it out. So if I want this derivative, is there any shortcut option I can do here? No. If you just have one term on the bottom, so nothing added or subtracted, then you could simplify it. But because I have 2 terms, I can't. We have to do quotient rule. So quotient rule is low, so the bottom, d high. What is the derivative of the top? Minus high, so the top, d low, derivative of the bottom, we get 2x over low squared. This one's a little bit nicer because anything times 0 just drops out. So all we have is negative 2x over x squared plus 1 squared. Take a second and try the next one. So I want z prime here. So you do high, low, d high, derivative of the top is your negative 3x squared, minus high, d low, derivative of the bottom is 4t cubed over low squared. If you distribute, we get negative 3t squared minus 3t to the 6th. Can I distribute the negative and my 4t cubed at the same time? That'll give me a negative 4t cubed plus 4t to the 6th over 1 plus t to the 4th squared. Combine like terms, which would just be our t to the 6th. So we have a 1t to the 6th minus 4t cubed minus 3t squared over 1 plus t to the 4th squared. Questions on go ahead and look at the next example. I want the equation of the tangent line. So when I see tangent lines, I know I have to do the derivative to get the slope of it. To the curve, e to the x over 1 plus x squared at the point 1, 1/2 e. So I need a point and a slope. So to get my slope, I need y prime. This is a quotient, so I have to do quotient rule. So low, 1 plus x squared. D high, what's the derivative of e to the x? E to the x. Minus high, so e to the x. D low, derivative of the bottom, over low squared. You can try to simplify this first. Ultimately, all I need this equation for is to get my slope, which I'm going to plug in a 1. So if you want to multiply it out, great, or you can just go straight to plugging in your 1 here. 1 plus 1 squared would be a 2. E to the first is e. E to the first is e. 2 times 1 is 2. Okay, on the bottom, 1 plus 1 squared would be 2 squared. What does this turn into? I get 0 over 4, which is 0. So that is my slope. So now I have a point and a slope. If you plug into y equals mx plus b, you just get your y-intercept to be 1/2 e. You could recognize if it's a slope of 0, you know really it's a horizontal line. The equation of a horizontal line is just y equals a number. So you wouldn't necessarily have to do this step, but if you forgot, you could. So you have y equals 0x plus 1/2 e, so just y equals 1/2 e. Are there any questions there? The last slide just has a summary of everything we've learned to this point. You know, derivative of a constant is 0. If you have x to a power, power comes down, subtract 1. Derivative of e dx is e to the x. We talked about quotients, addition, subtraction, or sorry, product multiplied by a constant, addition, subtraction, and then the new piece, the product and quotient rules. So this slide is pretty important. That's just a summary of what we know to this point. So, game plan. I've taught the full section now. So our plan is Friday, we're going to work on the handout. So on Monday, the handout is due. We will work on the book problems. And on Tuesday, the book problems are due. So you're welcome to start those if you want, but we will be having some class time to do that.